Hello again. It's time for section 2.6. Hopefully the quiz went away. Okay, that was a tough quiz, but let's see. We're getting to 2.6. Kind of a lot in this section. It'll be a 2-day section. I'll try to show you enough today that you'll be able to do a lot of the work. And tomorrow I'll throw in a word problem of like, what is this used for? But it's pretty significant. But today the problems have the x's on the bottom. So these are not polynomials. These are called rational functions. And I'll show you a little bit of what these are going to look like in Desmos. So let's bring up Desmos. Go. Okay, so here's a graph. And you see what I typed? I typed 1 over x. X is on the bottom. And check out this graph. I can zoom out. You zoom way out, it kind of looks square, but as you zoom in, it is kind of roundy there, isn't it? It's kind of curved. So how does this graph happen? And I'll be showing you how to do this by hand, but let me just move this over a little bit. Here you can see the positive part, and you get this neat kind of a boomerang shape. Okay, or maybe like an L shape, kind of an L shape. So how does this happen? Well, if I put some numbers in, imagine I typed in like, I put in 1. Okay, right here. Try to get that to click. Why does it want to stay right there? There we go. If I plug in 1, I get 1. Okay. If I plug in 2, I get 1 over 2 or a half. If I plug in 3, I get 1 over 3. In fact, the bigger the number I pick, like 4 or 5 or 6, I make a fraction, don't I? 1 over 6, 1 over 7, 1 over 8. And the farther and farther I go, the smaller it gets. I can make a little table here. And you can see some of the numbers. There's 1, 1. There's 2.5. And of course, I could go and click on this, and I could put in another number, like if I put in 5, you see it's only 1/5. If I put in 10, it's 1/10. How low could it go? What if I put in 100? Then it's 1 over 100, and then way out here, here it is, 1 over 100. But it never, ever gets to 0, no matter how big of a number I put in. If I put in 1,000, it's 1 over 1,000. So it never gets to 0. Okay, we'll zoom back in here. So we're actually going to give that a name. We're going to call that thing an asymptote. And I'll be writing that down in a moment. An asymptote, that is a horizontal asymptote. So let me see if I can put in another line here. If I put the line y equals 0, this line here in black is what the graph's getting close to. We're going to call that a horizontal line. And I can turn it on and off. I want to make it change the color here. Apparently I can't do that right now. Okay, whoops, I just wiped it out. Put that back up there. Y equals 0. Oh, I don't want red. There's a way for me to change the color, but I don't know how to change the color right now. Okay, so there's y equals 0. It's getting closer and closer to that line. We call that a horizontal asymptote. And of course, if I put in negatives, you see the same thing happens. If I take some of these numbers off and put in like -5, you see there's -0.2. So there's the negatives. So the graph, no matter which way you go, gets really close to 0. And just as you see, you get a bigger number. Now, also you may notice that the x's I put in, look right here, we got undefined. We can't plug in 0 because if you plug in 0, you get an error. 1 divided by 0 is an error, but look what the graph does when it gets close. If I put in something like 0.5, it says 2, because 1 over 0.5 is 2. If I put in even a smaller number, like 0.1, it's way up here. But notice it never gets to 0. So I could also pretend that there's a line, an up and down line, at x equals 0. That's a vertical asymptote. So it never wants, x doesn't want to be 0, and y doesn't want to be 0. Now let me put some other things in here. Let me take these off of here. Let me just clean this whole thing up. Put our graph back in here. 1 divided by x. Okay, so there we go, 1 over x. And what if I change the bottom to, so it doesn't want to touch 0, does it? Asymptote. What if I change the bottom to x minus 2? Now look what it doesn't want to get in here. I can't plug in 2. Remember 2, the domain restriction, x can't be 2. So the graph's almost like scared to be 2. It kind of turns away. If I made this x minus 3, 32, okay. X minus 3, as you can see, the graph's kind of close to 3, but doesn't want to be 3. I'm going to turn off some of these lines, make it a little easier to see. There we go, doesn't want to be 3. X doesn't want to be 4. Okay, get the idea? So to make one of these graphs, you're going to try to figure out what x can't be. Oh, x doesn't want to be 5. I could also put in x plus 5. And so now it doesn't want to be negative 5. So the graph bends away from that. What if you had 2 of these? What if you put like x plus 5 and put another one like x minus 2? And now you see there's 2 numbers it's avoiding. It doesn't want to be negative 5 and doesn't want to be 2. So now it turns away from both of those. These are our vertical asymptotes. They're domain restrictions. They're impossible. Let's take that back off of there. In fact, let's get this back to real simple again. Let's just change it to an x. So it doesn't want to be 0, does it? Now on the top, what if I change the number up here to like 2 or 3 or 4? Nothing really happens. Nothing happens. Okay, nothing's happening. But I'm going to put something like 2x. Oops, that's not what I want. Okay, let me change the bottom here. Okay, we got 1. Let's change the bottom to like x minus 1. Okay, now it doesn't want to be 1, does it? Pretty interesting. If I put an x on the top, it's the same idea. The bottom still doesn't want to be 1, does it? Doesn't want to be 1. But look what the graph's getting close to. And let me put some lines back in here. Okay. The graph's getting close to 1, isn't it? What if I put a 2 here? Now what's the graph getting close to? Look at that. It's getting close to 2, isn't it? What if I put a 3 on the top? Now it's getting close to 3. What if I put a 4 on the top? It's getting close to 4, isn't it? Oh, that's kind of interesting. If I put in a really big number, no matter how big of a number I put in, you'll see the results are getting close to 4. If you look at the second number, the y-coordinate, it's getting close to 4. Okay, so how do I do all this without Desmos? Right? How does this happen? If I threw a negative on here, now it's close to negative 4. Okay, and I can zoom in a little bit. You can see the numbers there. Yeah, it's getting closer and closer to negative 4. So let's try this on paper and I'll tell you how to do this. And there's a lot of good little things in here. So let's switch this camera over. Okay, so here's the basics. We'll do some today. We'll do the rest tomorrow. So I'm faced with this question. I'm asked to graph this question, the most basic question. So we call it rational, because rational is like fractional, which means x is on the bottom. Some people also call it an inverse function, because like the x and y seem to do the opposites. If I put in 5, I have 1 over 5. It's kind of like a fraction. So the first thing you always try to do is figure out the domain restriction. Okay, so remember that, the domain restriction. And so you just kind of look at this guy and go, okay, what if I made a table? And you look for the banned number. First thing you're always going to do, what is the forbidden number? And you're like, well, I can't put 0 in, can I? Because if I put 1 over 0, I get a big old error. And so, yeah, that makes an error. Okay, so notice this is the x, isn't it? So I'm going to say x can't be 0. So what we do is we go over to our graph paper and we graph that line. You go, where is x0? Okay, here's 0. And we're just going to put a big old dashed line. It's like an electric fence. And if you touch that fence, you're going to die, right? So we call this a vertical, means up and down, asymptote. Okay, asymptote. That means a line you can't touch. So this is just kind of helping us out. So any x that's forbidden is an error. And before, we would just say it's an error, but now we're actually going to try to graph that error. This is the error, so we can't have that answer. Next thing is we look, we got this line going up and down. Is there one going this way? Remember how I said it's getting close to something? So we're going to find the horizontal asymptote. So we're going to say, that means as you go off the paper, what is the answer getting close to? Like if I had X and Y, and you go way off the paper, you're like going 1, 2, 3, 4, 5, 6, 7, 8, 19, and you're out here like at 1,000. What is the answer getting close to? So what we're going to do is we plug in a giant number like 1,000, or you could plug in infinity, right? And just plug it into your question. Here's our question. And go, well, 1,000 would be 1 over 1,000. Or if you want, you can plug in infinity, 1 over infinity. And go, okay, if you got 1 out of 1,000 right, that's your score. I got 1 out of 1,000 right. Well, that's almost a 0%, isn't it, right? Or 1 out of infinity, you're kind of like a 0, aren't you? So that's so close to 0 that we put a horizontal asymptote. And so this is getting close to 0. So when you go way off the paper, you get close to 0. So we're going to put a little dashed line at, notice this is the Y. Over here we had the X, right? So we said X can't be 0, but this is the Y. And the Y is getting close to 0. So we're going to say at Y equals 0. So when you put in a big number, the Y is getting close to 0. So we're going to put this dashed line at 0, just like that. So this is the line Y equals 0. This is the line X equals 0. And so now we know the graph gets close to that. But once again, how do I draw the rest of the graph? This is another line. You can't touch it when you're real far away. So where do I go? Now remember the graph had this weird boomerang shape. So what we're going to do is we're going to plug in a point on one side of the graph. We're going to cover up part of the graph and say, okay, we can be really close to this fence, but we can't touch this. Okay, like MC Hammer, can't touch this. Okay, so pick a number over here, any number you want. You can pick 1 or 2 or 3, or you can even pick 1,000. But pick some number over here. Maybe I'll just try 1. Okay, let's try 1. And we'll plug it in. 1 over 1 is 1. Plot that dot. Okay, 1, 1. Okay, I'm ready to draw the graph. You go, what do you mean? You can't touch these fences. So what you're going to do is get really close to the fence. You're going to go like this. Okay, pretend I'm a kid in the playground. Don't touch the fence. Don't run at the fence. You can say, well, I can't go down. I can't go this way. I'm just going to go run along the fence. Just head towards the fence and then run along. Stay close to it. No turning away. You're just going to get closer and closer and closer. And now if you run the other way, oh no, electric fence. Turn and just follow the fence. See how that works? Never have the arrow pointing at the fence. You don't want to direct the kids into the fence. Otherwise, you're a really bad person. So send all the kids to run along the fence. Don't touch the electric fences. It's that easy. Just pick a dot. If you're above, you do it here. If you plug it in, if it's below, if you got a negative, you'd be down here and you draw down below. Oh, what about the other side? Okay, try number this side of the electric fence. We got all these numbers to pick from. How about I just try like -1? I'll plug in -1. Okay, we'll plug it in. 1 over -1 is -1. Okay, so I just said, how about -1? I get -1. So -1, down 1 right here. -1, down 1. I plugged in -1, I get -1. Okay, this kid's in a playground. He's going to play. Once again, he don't want to touch the electric fence. So he's going to run along the fence and along the fence, okay? Sometimes I see people in their quiz, they write an arrow and they point the kid into the fence. Don't direct the kid into the fence. And there's your graph. Okay, let's try this again. You might be like, what? I don't know if I got that all. Okay, let's try this whole thing again. So we got to find these asymptotes. Then you try a point on each side of the vertical asymptote, draw your graph. Okay, so let me put a different number here. I'm going to put like x minus 2 on the bottom. And let's put something on the top, like oh, I don't know. How about 3x? And you're like, oh my God, it's getting confusing. No, 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 don't worry, it's easy. Okay, let's bring this up. So first thing you're gonna do, here's your graph paper. I don't use real graph paper, it's just easier to do this. If you want, you can put some lines here. Okay, here's my problem. Okay, so first thing we always do is find the vertical asymptote. If you want, you can abbreviate VA. Okay, so first thing you do, think about you're making a table. What's the band number, the forbidden number? So the vertical asymptote, I'll just abbreviate like that. You look for the band number, you're like 2. Can't divide by 2, right? If you plug in 2, you get an error. So first thing you always do, find the vertical asymptote, just find the number that's the error. 2 is an error, forbidden number, domain restriction. Your vertical asymptote will always be the band number. And you know that you cannot pick 2. So this is what you want in your notes. Vertical asymptote at the domain restriction, at the unhappy number, at the number that you're going to kill the kids. Okay, so 2 cannot work because you can't divide by 0. So let's find 2. Here's 2 and put in an up and down line. Okay, that's the number one thing to do. If you do that, like when the quiz, I'll give you a point already. Okay, just by doing that, good, you just earned a point. Even if you're like, well, I quit, well, you just earned a point already. But let's try to earn some more credit, earn some more points. Okay, so 2 is band, vertical asymptote. Next thing we try to do, find the horizontal asymptote. Okay, so let's look for the horizontal, and I'll just abbreviate it. In fact, some people are going to start to just call this VA, and they'll just call this HA. Okay, remember, vertical asymptote is the up and down. Horizontal is the this way. And what's horizontal again? That means as you're going off the paper, where is the graph headed? As the kids run away, are they headed to 0? Are they headed to 1? Are they headed to 2? Usually they just head to 0, but not always. So here's all you got to do. Let's pick a number way off the paper. I don't know. How about what do you want? 1,000? Okay. 1,000 is a good number, or you could use infinity. If that's too much, you can even use 100, but just take 1,000, plug it in. Wherever you get is where the kids are heading. When they go 1,000 miles away, what are they close to? Okay, let's plug in 1,000. 3 times 1,000 over 1,000 minus 2. You could use a calculator and go 3,000 over 998. If you got a good calculator, you can punch it in all at once. 3,000 over 998. If you put it all there in at once, you're gonna have to use parentheses. You gotta know how to work your calculator. And I get, okay, let me make a decimal. 3, what's it close to? It's close to 3, isn't it? Yeah, it's close to 3. In fact, let me just tell you something. Is it above or below 3? Right now, we're gonna save ourselves some time. Is that above or below 3? I can't hear you. It's just barely above, right? It's a little bit above 3. I'm gonna put 3 above, just as a little note, right? Just a little more than 3. Because what if you got 299? Okay, it's a little above 3. That's gonna so help me out. Okay, 1, 2, 3. And we're gonna go like this. Horizontal, go the other way too. You know, if you put in -3, if you put in 3, it's the same the other way. Okay, it's the same to both ways. Okay, I got my graph. In fact, you know what? I'm almost ready to make my graph. Okay, now we got to figure out, usually it's going to look just like this, but sometimes the arrow, the kids are below, sometimes they're above. Okay, remember when we put in 1,000? It was a little more than 3, like 3.001 or something. Let's put that dot right now. There's some kids playing right there, just barely above. Okay, let's run along the fence. See, stay close to the fence. and some of the kids are going to run the other way. Look out for the red fence. It's on fire. Okay, let's turn and run along that fence. Don't touch the fence, or you're a terrible person. We got to do this for the children, don't we? Okay, so we're going to run along the fence. And the other one, usually you're going to find it's opposite, but sometimes it isn't. Let's try the kids that are on the other side of the playground. Okay, so all the numbers here, you know, no matter what you try, 3, 4, 5, 6, every single one of these numbers is going to give you a dot right above. Yeah, believe it or not, it will. You don't believe it? Feel free to go ahead all day and plug numbers in. Okay, let's try a number on the other side. Let's try something this side of 2. You could try 1, you could try 0, you could try -1, you could try -2. You can try any number you want, doesn't matter. All you got to do is find out, are the kids above the fence, above up here in the top playground, or in the bottom playground? Okay, so let's try, how about 1? 1's good enough. You can do 0. Let's just going to try 1. Okay, so let's see what happens. Let's plug in 1 and see where the kids are at. 3 times 1 over 1 minus 2. 3 times 1 is 3. 1 minus 2 is -1. 3 over -1 is -3. Okay, so I tried 1. I got 3 over -1, -3. Okay, let's put that dot. 1 gives me -3. 1, -3. Somewhere down here, right? 1, 2, 3. I guess about there, because here's the middle of my graph, about there. Okay, there's a child playing. Okay, let's have him run along the fence. Run along. He's like, which way is he going to go? He's going to run along the fence. There he is, run along the fence. Like this. There he is, run along the fence. And he's going to run the other way. And, well, I can't bend him back. It's only one turn. He's like, where's he going to go? Oh, no, another fence. Let's turn. Here's all that. Make sure he gets close to the fence. I'm not worried how exact you get. Like, did he turn right here or here? Like, if you want to know, does he touch here or here or here, or did he turn more like over here? You know, where exactly did he go? Way up and turn? It doesn't matter unless you want to sit there and plug in lots and lots and lots of dots. But we got the basic idea, right? So there's the graph. I can even darken them in a little. Okay, there's one graph, and there's the other graph. Okay, never touch the fence. Okay, getting the hang of it. Okay, people will start to get some shortcuts and some nifty little tricks. We're going to try another one. In fact, some people start to discover something. Okay, of course, this is the band number, right? 2, vertical. And you notice it went close to 3? Look at this. 3. In fact, I'll show you some shortcuts tomorrow. Some people kind of look at this and go, this number is 3 times as big as that. So let's not worry about that, but I'll teach you like shortcuts tomorrow. But this is the safest way to do it that we're doing. Okay, let's throw another one. I want you to try to do it. I'm going to put 5x over x minus 3. Okay, so you should be good at this question right now. Here's my graph paper. I can put a few numbers. Okay, so let me give you a chance to try it. If you need more time, you can pause the video. I'm just going to write a few things. Okay. What do we do first? Find the vertical asymptote, right? The forbidden number. Then you got to find the horizontal asymptote. That means as you get close to a number, okay, let's see what you can do. Feel free to pause it. I'm going to wait a little bit. If you need more time when I start talking, just say, Miss Lee, pause the video. We're trying to figure it out. Okay, I'm going to fill a little bit in. I know my forbidden number is 3 because 3 minus 3 is an error. That's an error. So X can't be 3. So I'm going to go over to 1, 2, 3. Put my vertical line. Okay, there it is. And let's get the other guy. Let's get the horizontal. And that means where are the kids heading when they go off the screen? So horizontal once again means what happens at a really big number. Big number. What happened? Okay, what happens? Big number, what happens? So put in a big number, just put in a big number. You can put in 100, put in 1,000. What if I just put in 100 this time? That's still a pretty big number, right? 5 times 100. Later, I'll let you know shortcuts of how to do this. 100 minus 3, I'm gonna get my calculator and go 5 times 100. Well, 500 divided by 97. I don't like to put too much in my calculator in case I don't have a good calculator. 500 divided by 97. Let's see, wait, decimal. Okay, I get about, I put a little wiggly, about 5.15, right? Doesn't have to be perfect. Okay, so we're headed to about 5, aren't we? In fact, wait, I'm above, aren't I? I'm a little bit above, right? I like to make a note of that. Okay, so the horizontal is at y equals 5. Okay, y equals 5. Why? Because remember, we're doing y, right? Aren't we solving for y? Y is 5, right? Y is 5. So remember, go to the 5. Remember, here's the band X number, but this is where you're headed. Y is 5. Okay. Boom. There's 5. Now, when you make the horizontal, you're really only supposed to do it on the edges of your paper. Most people just draw it all the way through, but you're really only supposed to put it out here. Because once in a while, there's a crazy kid. And he goes all over. But when he gets to the end, he's going to be a little bit above the arrow. But sometimes this fence has a gap in it and they kind of get a little bit of it out. But that's only going to happen if you drew like a really big, crazy question. Okay, but feel free to just do that, okay, if you want. It just makes it a little easier. Okay, let's run along the fence. Run along the fence. Whee! And then somewhere we turn and go along that fence. I mean, if you want, you could try another number. You could plug in 4 or 5 or 6 or 7. I mean, there's nothing wrong with that, but you're going to find all of those dots. They're going to be above. If the dot's below, then all the dots would be below. And we'll try the other side. You know what? I bet you it's over here. Okay, try another dot. Try a dot over on this other playground. Something less than 3. You can try 2. You can try 1. You can try 0. You could try -10. Any number you want. You could try 2. You could try 1. You could try 0. Anything you want. If you want, you could try -10. What the heck? I'll try -10. 5 times -10 over -10 minus 3. I probably should have tried an easier number. But whatever it is, all the dots are above or below. -50 over -13. Yeah, why did I try 10, right? But I just wanted to see. -50 over -13. 3.8. Okay, 3.8. About 3.8. Okay, that's close to 3, isn't it? It's getting close. Above or below? And then, whoops. Below 5. We're comparing to 5, sorry. Let's see, where is this? -10? No, I made it difficult on myself. But either way, try any dot over here. 3.8 is about right there, right? Okay, because there's 5. Okay, let's let the kids play. Okay, let's run along the fence. Don't do something weird and go woo like that. You know, don't make anything strange. Just kind of like send them along the fence, nice and gentle. And then, okay, because he's going to curve like that somewhere. I don't know exactly where to curve, but we got to get over to this fence, don't we? There we go. Sometimes you find it kind of swings out a little bit. Sometimes it gets in close. But there you go. There's my graph. Okay, let me pause here for a second. Okay, here's the last thing. Sometimes you're going to get a question where the graph's already drawn for you. Okay, so here's one. And it's got a vertical asymptote at 5. So in fact, if I were thinking about the question, I could say, oh, I bet this had x minus 5 on the bottom, right? It was band. Oh, here's -8. I bet it was probably x plus 8 on the bottom, right? It has 2 band ones. Okay, there's the vertical asymptotes, Okay, and what about in the middle? Now notice, see, I did the horizontal here, and we're going to put a little more of the graph. We're going to say this graph is like the kids are along this fence. And maybe they just do something like this. Okay, so sometimes I say the horizontals actually only apply to the edge. These are the same. Okay, so there's a graph drawn, and this is the horizontal. And sometimes you're going to say, okay, I would like you to look at just this part of the graph over here and tell me where the kids are. And you're like, okay, and you're going to see them do this. They're going to say, as x and an arrow is close to 5, they're going to say approaches, as the children approach 5, and where are they headed? Okay, and you're going to say, well, they're headed to, no, wait a minute, you're like, well, they're going down, right? So as the kids get close to 5, so imagine there's a child. As he gets really close to 5, where's he headed? Where are the Y's headed? You're like, well, he's going down to -infinity, isn't he? But you go, wait a minute, what about this kids on this side? These kids are going to positive infinity, right? Well, some of the kids are going to positive infinity. I can't see my negative there. Negative, positive, right? Some are going down, but some are going up, aren't they? Well, here's what you're going to see. You're going to see it looks like a typo, but it's not. They're going to say, okay, as kids get close to 5, you see this little plus that's on the wrong side of the 5. They're going to say, as the kids are getting close to 5, but a little more than 5. So that means like 5.1. You're going to say they're going down. Well, the kids that are on the other side of 5, the kids that are like at 4.9, you're going to see a little minus on the back side. Once again, the 5. It's not a typo. It says as the kids get close to 5, but are a little, take off a little bit from 5, subtract a little bit from 5. As the kids are close to 4.9, the kids on this side are headed to positive infinity. Okay, so I know it's super easy, but also a lot of people find that super confusing. Okay, let's try it over here. There's some kids playing around the -8 fence. Okay, some of the kids are approaching -8 from the negative side. And some of the kids are approaching -8 from the positive side, from a little bit bigger. I'm going to say, where are they headed? Okay, so look at that. We're kind of thinking about right in here. Okay. Okay, so let's get near -8. Here's -8. Find the kids that are a little less than -8. Here's -8. A little less than -8's over here. Here's these kids, right? They're farther down. Where are they headed? Where are they headed? What Y answer are they headed to? Well, as they get really, really, really close, they're going off the top of my paper, aren't they? They're headed to positive infinity. And the kids that are approaching -8 from a little bigger, from the kids that are a number a little to this side, a little plus -8, a little more than -8, they're headed off the bottom of my paper, negative infinity. Okay, so positive and negative. I know it's kind of bizarre at first. And here's the last thing I'm going to ask. So you're going to see questions like that. And here's the last question I'll say. How about the kids that are actually headed to infinity? And you go, what do you mean? 5, 6, 7, blah, 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 way out here, right? As some kids are actually just running away. Hopefully it's not a flat earth and they fall off the edge. As some kids head to infinity, what answer are they approaching? And you go, what do you mean? What Y answer? They're not going to infinity. They're not going to negative infinity, but as kids are going like this, off of my paper, as the kids actually run to X is infinity, Here they are, running to infinity, right? They're headed out here to infinity. What y are they headed to? What height? And you go, wait, they're headed to this line, aren't they? Where's that line? Ah, it's at 3. These kids are approaching 3. Okay, so we're also going to say what x are you getting near? What y? Some kids are running off the top of my paper, some running off the bottom, some are just heading close to 3. Likewise over here, as these kids head to negative infinity, as they're headed off the paper, what height are they headed to? Once again, they're headed to 3. Okay, so I know that part is confusing. Let's check out the homework. I'm going to show you how you can do a whole bunch of this homework. We're going to run through this pretty quick here. And here's, you might say I feel overwhelmed. Try to do some of this tonight. We'll practice some more tomorrow. But here's all you got to do. All you got to do is, let me see, where's my pen? Here we go. It says find the domain. All you're going to do, I'm not going to do the odds. I'll show you the evens. All you got to do is say what number is forbidden. You're just going to say number 2, x can't be 8. Next one, x can't be 2, x can't be -6. These would be vertical asymptotes. Next one, x can't be plus or minus 8. Just look for the band domain restrictions. Next one, x can't be, wait a minute, there's no problem here. There's no problem. I'll let you think about it. Next question, you get to do what I just did. I'm trying not to bump the computer. And I'll explain this some more tomorrow. If you don't get this, we'll try it again tomorrow. It says, okay, as you get close to -3, as a child's getting close to -3, and he's a little less than -3. See that tiny, tiny little negative right there? So you're going to go, okay, here's -3. We're going to be a little smaller than -3. We're going to be less. Where are they headed? Off the paper. And then you would write in with a pencil. You'd say, oh, the kids that are a little on the negative side of negative, they're going to head to negative infinity. What about the kids that approach -3 from a little more? They're going off the top of the paper. -3, but a little bigger than -3. They're headed to positive infinity. I'll go through these again tomorrow with you. Let's go farther down. They give you another one, or you look at this graph, and once again, you name where are the kids headed? Where are the kids running to? Next little place, if you have trouble with those and you're just like, I don't get it, just jump ahead. Find the vertical asymptotes. Same question again. All you got to do is say, what are the band numbers? I'm going to look at 22. What's the forbidden number? You're like, x can't be 3. Okay, so vertical asymptote at 3. So wherever there's a band number, you put it right there. And then here's another one. This guy's got 2. X can't be 0. X can't be 3. So once again, vertical at 0, vertical at 3. Same question again. X can't be 3. X can't be 0, vertical at 3, vertical at 0. Oh no, trick question. I'll explain why. Don't the X's get canceled? I'll talk about that tomorrow. It's going to say it's a hole. So what? I'll explain that tomorrow. Don't worry about it, okay? For right now. And this one's okay. This guy's no vertical asymptotes. Okay, we go a little farther. They say find the horizontal asymptote. Where's the horizontal asymptote? And you go, wait, how do I do horizontal asymptote? That's as we go off the paper. That's where you go plug in a giant number like 1,000 or even infinity if you can handle infinity. So let's look at this one. If you put in a giant number, oh man, I guess I got to get a calculator out, because what do you get when you plug in a big number? And I'm going to tell you, this one is headed to 0. How do I know that? I'll tell you a little secret. There's a bigger exponent on the bottom than the top. I'll tell you about that tomorrow, but there's a bigger exponent. The bottom's out of control. Bigger exponent heads at 0. Next one. Once again, just put in a big number Where's this guy head to? I put in a big number. I'll give you a trick. There's a tie. Put in a giant number on your calculator. See what you get? I'm gonna let you know this one heads to 5. There's a horizontal. The graph's headed to 5. This guy was headed to 0. I know it's a little tricky, the horizontal. This guy, when I put in a big number, I just got a big number. Okay, we'll work on this horizontals tomorrow. So again, I put in a number here. I got -3/5. Okay, well, I'll tell you some tricks about how to do the horizontal. But like I say, if you're not sure, just plug in a big number and put what you get. Okay, but if you put in 1,000, if you get a number that's so big, there might not be one. Okay, and then down here is where you try to graph. And once again, if you want to go for the graph, try it. If you have some trouble, we'll do those tomorrow. But I'm going to stop the video here so you can work and actually get some of this done. All right, and we will continue this tomorrow. We'll continue 2.6. It's a 2-day lesson because it's a lot to absorb into your brain. And have fun with it. And good luck. See you again.